Okay, let me make sure that you realize that there's this right here. At the very beginning of your course, there's this geometry proof manual, and if there's any way possible that you can print that out, that's going to be really helpful, because then you can go through it and mark the theorems and stuff as you go. It would be a really good resource if there's any way, even if you have to go to the library one day and print it out, if at all possible. Okay, if not possible, then I understand, and we'll just do the best that we can do. You're gonna have to take notes. You're gonna need to write stuff down. I don't know how you're doing, how you do your work, but you're gonna need to really keep track of this stuff. Let's see. Okay, so what I'm gonna do is I'm gonna look at a few things in the lessons prior to that quiz and make sure you understand what the heck they're talking about. Okay, so this is from my view, so it looks a little bit different, but we get the gist. Okay, so I'm just going to skip down here to the first theorem. This would be something that I would write down. The isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite of those sides are congruent. Okay, so just in case, if you've got a triangle and they're telling you that this side and this side are congruent, and they're telling you that because the tick mark is the same, this is a single tick mark, this is a single tick mark, then if these two sides are congruent, then they're telling you that this angle and this angle are also congruent, and therefore it's an isosceles triangle. Isosceles triangle has two sides and their base angles that are congruent. Okay, so that's what it's telling you. That's the isosceles triangle theorem. Okay, a corollary. The corollary is like, okay, here's something that's similar to the isosceles triangle, but a little bit different. So corollary 1 says if all three sides of the triangle are congruent, then it's an equilateral triangle. Okay, so if I go back to this picture over here, or if I just draw another triangle, and I tell you that all three sides are congruent, then it's an equilateral triangle. And it automatically, if all three sides are the same, then it's an equilateral triangle, and all three angles equal the same thing. Okay, an isosceles, two sides and two angles, an equilateral, three sides and three angles. Okay, now they typically use lateral to talk about the sides, and they'll use the word angle to talk about the angles. Okay, but it's the same triangle. Okay, so then it gives you a couple proofs. So let's go through these proofs so you can understand all this terminology, because I don't know if they show you this stuff in videos, or if they just assume that you figure this out. And because geometry's full of these proofs, and it's like a new language. Okay, so this is the first proof that they gave you in this lesson. Okay, I'm drawing the picture as I'm stalling here. Okay, so given, they're telling you the triangle BAC, they're giving you that triangle. They tell you that AC is congruent to BC, and M is the midpoint of AB. Okay, and you're supposed to prove the angles A and B are congruent. Okay, and then they go through it. So I'm going to go to my paper here. Okay, so they gave you this triangle. The reason they give you this is so you have all the letters, and they tell you that this is a triangle. Duh. Okay, so triangle, this is given. They tell you that side AC, the little line over, the little lines over the letters means side or leg or segment or line. Okay, and that means that they're congruent. So I can go over here and I can draw a tick mark here and a tick mark there. Okay, and I draw the same tick mark because they're congruent. If they weren't congruent, if they were congruent to something else, I'd have several tick marks. Okay, and then M is the midpoint of AB. So here's AB, and we're going to put a point right smack dab in the middle, and that's where M is. Okay? So in your proof, you always list the given stuff, okay? And then you're trying to work to the end. You're trying to work to the angles, but we got to work with the given stuff. Okay, so they talk about drawing an auxiliary line. So what they mean is, okay, if this is a midpoint, let's draw an imaginary line right here. Okay, which that's supposed to line up, but I'm looking at my work through my phone, so it's a little off. Okay, and their reason for drawing that is that through any 2 points is exactly one line. Okay, and then because this is a midpoint, I know that this side, and I'm going to draw 2 tick marks, this side equals this side, because I divided it in half into 2 equal pieces. That's what the definition of a midpoint is. Okay, so I know that AC is congruent to, AM is congruent to BM, and the order of the letters doesn't necessarily matter. And the reason is because definition of midpoint, and midpoint just, it cuts things into 2 equal pieces. Okay. Now then, so as you see, I've kind of, when I drew this line, I made 2 triangles. Okay, so this side of the triangle is congruent to this side of this triangle. This side of this little triangle is congruent to this side of this triangle. So I'm pretty much working on getting to side for congruence. So this little imaginary line that cut the big triangle into 2 pieces, it is congruent to itself. All right, and it's kind of a silly. This is a silly reason, or property, but it's very, very important. Because the whole thing of proofs is you're like, every step that you take, you have a reason for it. Okay, so we're going to say that CM, side CM is congruent to side CM, or MC. They have their letters backward, different, but anyway. Okay, now that's kind of silly. That's like putting, if I put like 3 tick marks on top of each other. Boom, boom, boom. All right. And let me get a highlighter really quick. So when we drew that imaginary line, we created 2 triangles. Okay? Sorry, wasn't prepared. So we created 2 triangles. And so we're trying to prove that those 2 triangles are congruent. Okay? All right. So we have this side and this side, this side and this side, so we need a 3rd side. And this is the same side. Okay, it's kind of I always call this property a no-duh property, and it's called reflexive property. I can spell. Okay, because basically it's like looking in a mirror. It's a line on top of itself, that kind of thing. So that makes it. Okay, so now I've got 3 sides of each triangle that's congruent, so I know that those 2 little triangles are congruent to each other. So what is that? Triangle AMC is congruent to triangle BMC. Why are they congruent? Side, side, side. Okay. Now then, since I know these triangles are congruent, then I know that everything else about them are congruent. Okay, so I proved that the 2 triangles are congruent to each other. So that means all the pieces. That means this angle and this angle is congruent, this angle is congruent to each other, this angle, this angle. So that's where CPCTC comes in. You have to prove the triangles are congruent first, and then once you have that, then you can list all the other stuff. So it was asking us to prove that angle A is congruent to angle B. Well, we now know that they are because we know that the 2 triangles are congruent. Okay? And so since we've proved the triangle first, then we can use CPCTC, congruent parts of congruent triangles are congruent. Okay? So you always do this after you prove the triangles. You can't use this before. Okay? Alrighty. So then they give you this other theorem. Alright, they give you triangle ABC. Oops. Okay, and they tell you it's an equilateral. So triangle ABC is equilateral. I'll probably spelled that wrong. But anyway, so based on that theorem, or that corollary that we talked about up here, okay, this corollary says that all three sides are congruent. That's an equilateral triangle. We kind of know this, but we're proving it. We kind of know that all the angles are. Okay. So let me put tick marks. So that means that all three sides are congruent. So if we start our proof, we always list what's given. Triangle A, B, C, whoops, okay, is equilateral. Okay, the reason is given. We were told that it was. Okay, so because it's equilateral, I know that all the sides are equal, so I'm going to list that. So side AB is equal to side AC, which is equal to side BC, or congruent, I should say. Alright, the reason we know that is the definition of equilateral triangle. Okay? Now then, we know that these angles are congruent. Okay? Angle. You should try writing your notes through your phone. It's challenging. Okay? How do we know that those guys are congruent? Well, it has to do with the very first theorem. If I know that the two sides are congruent, then I know that the two angles are congruent based on the isosceles triangle theorem. So that's what I'm going to write down here, isosceles triangle theorem. And I'm just going to abbreviate. Okay? Okay? If I turn this angle, this triangle over, it looks like an isosceles triangle that way. Or if I turn it this way, it looks like an isosceles triangle that way. Okay? So I can use that for every single one here. So angle A is congruent to angle C. Same reason. Isosceles. Okay? So since B is equal to C and C is equal to A, then B and A are equal. They're all equal. Okay? Angle A, angle B, angle C. And when you do that, you know, when you say B is equal to C and C is equal to A, so therefore A and B are equal because of this little circle that I did there, that's called transitive theory. Or not theory, but property. Okay? When you can do that little circle. So the point of this was to prove, sorry I didn't write that down, we were supposed to prove that angle A equals angle B equals angle C. So we're proving the equiangular thing. Okay, so hopefully that explains, you know, what transitive property is, and why they're doing these different things. Okay, now I want to talk about this theorem. This is the converse. Converse means opposite. So if the original theorem was the isosceles, and it says if two sides of a triangle are congruent, then the angles opposite of those sides are congruent, then the opposite of that would be if two angles of the triangle are congruent, then the sides opposite of the angles are congruent. So you're working it backwards. So that's what that means, backwards. All right, and then the corollary 2 has to do with the equiangular, right? if 3 angles are congruent in a triangle, then all the sides. Okay, so that's corollary 2 is the converse of corollary 1, so to speak. Okay? Alright, so let's talk about this little funky problem here. Talks about you're a captain of a starship, yada yada yada. And it asks all kinds of questions based on this picture. Okay? And then it tells you how to go about solving this. It says first use the triangle sum theorem to calculate the measure of angle C. So let's look at this picture. We know the measure of angle A is 45. We know the measure of angle B is 90, because that's what that means. So what does this mean? So again, if they didn't, somewhere along the line they should have taught you this. I know you're pretty far along, and that's where that proof manual comes into play. But let me write this down. So the triangle sum theorem, I'm just gonna, I always spell theorem wrong, so I'm just gonna scribble. Oh, okay, it means if you add up, alright, let me just do this as A, B, C. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. So all the angles in a triangle always add up to 180. So that's the triangle sum theorem. Okay? All angles add up to 180. So in the triangle, in our problem, this is A, this is B, and this is C, and they tell you that this is 45, and they tell you this is 90 degrees, and they want to know what this is. Okay, well, 45 plus 90 plus I don't know equals 180. And so if you solve backwards for x is going to be 45 degrees. Okay, I'll let you do the math on that. Just trust me. Okay, so that's what you're doing there. You're trying to find the angle. Once you answer that, then what kind of triangle is it? Well, look at it. Alright, if this is 45 and this is 45, based on the converse of the isosceles triangle theorem, this is an isosceles triangle. That means that this side and this side are equal. So that's what they're asking about there. What kind of triangle is it? It's an isosceles triangle. Oh, I don't know which one it is. Okay. Alright, and so since it's an isosceles triangle, what does that tell you about the measure of BC? Because we know AB, so what is BC? Well, if this is an isosceles triangle, then we know that this side and this side are congruent, so this is 125 million, whatever the heck that is. Okay, so 125. And then that's what the distance is. So actually, I think this one it's probably congruent. Let's see. Really I'm not sure. Oh, maybe that's what we're looking for right there. Okay, and then the last one, what is the distance? That would be the 125 million retimolix or whatever the heck. Okay, so that's how you use those theorems. Okay, and this is another theorem. Okay, very similar to the one we did. You're given triangle ABC, you know, and you're given that angle A and angle B are congruent. You're given that. See the little tick marks? Okay, boom. They want you to prove that side AC and side BC are congruent. So you always start out with your given. Okay. The thing that they screwed up on is they should have told you that M is the midpoint. They didn't tell you that. Oops. But anyway, apparently you've got this M here, so we're going to draw this line. And then this is the reverse since we're dealing with angles. Since we drew this, if this is the midpoint and we draw this line, this becomes an angle bisector, which means it cuts the big angle into two equal pieces. So that's where this comes into play, angle ACM. Remember, the middle letter tells you where it's at. So ACM and BCM. So these two angles are congruent because of the definition of an angle bisector. That's where that comes into play. Alright, do you remember why this side is equal to this side? It's a silly property. okay, called reflexive, right here, this would be reflexive. And then we know that those two triangles are congruent because we've got angle, angle, side, angle, angle, side. All right. Once we know that the two triangles are congruent, then we can use the CPCTC and prove that the two sides are congruent. Okay, so that's how that works. And then here's another one, and it's just proving the opposite. Okay, I want to look at the coordinate one really quick because this video is becoming really long, and that means it'll take forever to upload. But the coordinate plane, triangles in the coordinate plane proofs. This is just work intensive. Here's what you need to know. You need to write this down. This is the Pythagorean theorem. Okay. Distance. Write this down. Distance formula. Okay. And the midpoint formula right here. Midpoint formula. Those are the three things that you're going to need for this. And you're going to be doing a bunch of math for the proofs. So I'm just going to bump down to these proofs. All right? A coordinate proof. Coordinate proof means you're going to use math with coordinates to prove that, you know, the proof stuff. Okay? So all right. So you're given triangle DEF, and it gives you the coordinates of all the vertices, all the points that make the triangle. Okay? And then using that information, you're going to prove that those two triangles are congruent. Okay, they gave you two triangles. Sorry, I wasn't reading the whole problem. Okay? Alrighty. So I'm just gonna cheat a little bit and draw this while you're staring at that, and I'm going to just put the coordinates. Okay, so the best way using coordinate geometry, coordinate proofs, I guess, is you're going to be proving them by side, side, side. So you need to figure out what all the lengths of all the sides are. Okay, so we're going to look at this picture right here. So by the way, this is F right here, and it's at the origin. Okay, so the easy parts you can just count are the ones that are horizontal, good horizontal lines and good vertical lines. Those you can just count. Okay, you don't actually have to do math. Let me show you. Okay, so the negatives, if we do the math, the negatives will take care of themselves later. But if you just count from here to here, it's 1, 2, 3 units long, and from here to here, 1, 2, 3 units long. So make life easy and just, you know, count where you can. Okay, and then straight up and down, you can count 1, 2, 3, 4. So we know the length of this one, we know the length of this one, and we know the length of this one. All we got to do is do some number crunching to find this one and this one. And you can't count on these, you have to calculate. Okay, you can probably guesstimate pretty close, but to get it right, you have to calculate using the the distance formula or Pythagorean theorem are basically the same thing, and I'll show you here in just a sec. So let's write that down. Okay, so we know that EF is the same as GF, and they're 3 because we counted them on the thing. Okay, let me put little lines over this. Sorry. Okay, and then we know that DF, and you know we're going to need it twice because we're looking at 2 triangles, so I'm just going to go ahead and write it because of reflexive property. But we know that it equals 4 because we counted. Okay, save some time on the math and counted. Okay, so now we need to find the length of ED. If you use the distance formula, let me write the distance up here. The distance formula is I believe it was x2 minus x1 squared plus y2 minus y1 squared. Okay, and the square root of the whole thing. Okay, so what we're doing is, this is, let me scribble this out. This is essentially saying that the length ED is going to be, since E's first, I'm going to go the x coordinate of E. The x coordinate of E is -3 minus the x coordinate of D. X coordinate is 0. That whole quantity squared. Plus, okay, since E's first, the y coordinate of E. Y coordinate of E is 0 minus the y coordinate of D, which is 4, squared. The whole thing squared root. Now, granted, you can plug all this in your calculator, but I'm going to do it old school. So -3 minus 0 is just -3. And we're going to square that puppy. And 0 minus a -4 is going to be +4. And if you don't believe me, do it in your calculator. 0 minus a -4. Oh, wait. No. Just ignore what I just said. I added an extra negative. 0 minus 4 is -4. My bad. Sorry about that. Use your calculator. You would have said, Mrs. Bird. Okay? So anytime you square a negative, I don't know how fancy your calculator is. Use parentheses if you can, unless you're good at math and you know that when you square a negative, it's going to be a positive. Okay, so that'll be a 9 plus 16. All right, and that's going to be 25. And of course, whoops, square root of 25 is 5. So ED. ED equals 5. Okay? I write really big when I do this. So I'm going to use a pencil, and I'm going to do it again for GD. I'm going to do this up here. So GD is going to be the x coordinate of G, because G's first, so 3, minus the x coordinate of D, 0. The x's are always first, squared, plus the y coordinate of G, which is 0, minus the y coordinate of D, 4. And you could probably already tell. If you have good number sense, you can already tell. If you don't have number sense, it's not the end of the world. Just keep going. Okay? So this is going to be 3 squared plus a -4 squared again. So this is going to be 9 plus 16 again, which is square root of 25, which is going to be 5. So GD equals 5. So you just proved that ED and GD are the same length. Okay, when we counted, we proved that EF and GF are the same. And we went through the motions, and we know that DF and DF are the same. So we know that these are congruent by side, side, side. Okay? And I'm sitting here looking at the answers. Let's look at this. From the marks on the grid, we can see that the length of EF equals, the length equals 3, and GF is 3. So EF equals GF. Got that. DF equals DF by what property? What? Reflexive? Yep. Therefore, something by leg-leg congruence theorem. I guess they're using, since it's really, these are right angles, they're going to use the right angle one. So it's not side, side, side. Since it's really a 90 degree, it's going to be leg-leg. All right? But if you were in my class, I would have accepted side, side, side. But we have to go with the go. So we know that those two triangles are congruent by the leg-leg congruence theorem. Okay? This next one, it's wanting you just to find the length of AM. Okay, same thing. You're going to use the distance formula. You're going to use those coordinates. The x2 is going to be the x coordinate of A. The x1 is going to be the x coordinate of M, and so forth, just like I just did. Okay. Alrighty. These guys, again, you can probably count or just do subtraction to find the lengths of all of the straight, up and down, and horizontal. You'll use the distance formula again for the slant, and you're going to be proving that these guys are congruent and finding the area. They give you the area formula, BH, so the base and the height. So it's going to be this number and this number for the base and the height on that. Okay, so that's kind of that one. Just those three formulas that I showed you at the very beginning is how you're going to do that. So hopefully going over those two lessons with you together will help you on the quiz. Just let me know. All right, talk to you later.